This is an introductory video for a series of videos on testing for inorganic ions. So we're going to look at ions that you may have met in the Group 2 and Group 7 studies you have been carrying out for your A-level, but also some other ions that we're going to then link to them. So the context here is we'll be given colourless solution and we need to identify the positives and the negative ions in our solution. So what are our ions with positive charge that we're going to look at being able to identify? So positively charged ions, remember, are cations, like pussycat, positively charged ions. So if you can imagine, we've got a little pussycat. So cations are positive. We've got the ammonium ion, NH4+, the magnesium ion, magnesium being in group 2, and barium being in group 2, so 2+ ions. So we're going to look at tests for those 3 cations, positive ions. And then we've got our negative ions, our anions. We've got the carbonate, CO3 2-, the sulfate, SO4 2-, halide ions, X-. The ones that we're going to look at are tests for chloride ions, bromide ions, and iodide ions. And then we have the hydroxide ion. Okay, so we're going to look at tests for these different positive and negative ions. They can be identified using one of 2 types of reactions. So either acid-base, for example, when we're looking at the ammonium or the carbonate ion. So the ammonium ion is actually an acidic ion and would react with a base, and the carbonate ion is a basic ion and would react with an acid. So we're going to use those reactions. Or precipitation reactions. Precipitation reactions are where you have a positive and a negative ion in solution, so AQ. So you have a positive ion that's AQ, and you add a negative ion that's AQ. Oops. So that could be something like an M and an X, and they come together and they make a precipitate. So you have to put them together balancing their charges. This is just a sort of random example here with not real elements. But the oppositely charged ions in solution come together as a solid, and that is a precipitation reaction. The very important thing about writing observations for this particular part of chemistry is that observations should focus on what you can see. And so we are talking about colours and state symbols. So, for example, we might see a white precipitate, so that would be a white solid. We might see an orange solution, so that's a colour and a state. We might see effervescence if we see a gas. What we can never write down is nothing, because we will always observe something. Even if no change is occurring, we still observe that nothing changed, or that we still have a colourless solution. But we never write down nothing. The word nothing implies that there was nothing to observe, and that's not true. You can still observe the chemicals that are present. So there's going to be a whole series of videos now that follows, one for each of these ions. Make sure you know how to test and the expected observations.